Problem number 28. We're going to skip 26 and 27. Those you can find in your notes. Problem number 28 looks as follows. So we need to verify the following trigonometric identities. So here's A. A asks, A's got the cosine of theta over 1 minus the sine squared of that angle. We need to show that that's equal to just the secant of the angle. So let's work the left side. It's easiest to change the denominator. 1 minus sine squared is cosine squared. Pythagorean identity. And now if we divide each of these by cosine, as long as cosine is not 0, we just have to remember that this thing is still equal to the secant of theta. Okay, so basically I'm canceling one of these and one of these out, so I'm left with just 1 on the bottom. And we know that 1 over cosine is secant. Okay, let's do B. B is 1 over 1 minus the sine of x minus 1 over 1 plus the sine of x, and that's equal to 2 times the tangent of x times the secant of x. Work the left side, get a common denominator. That gives me 1 plus sine x minus 1 minus sine x. On the numerator, the denominator is 1 minus sine x times 1 plus sine x. So on the top here, I'll go plus a negative positive here. And so that's just going to give me 2 sine x over, when you FOIL this out, you're going to get 1 minus sine squared x. So that's 2 sine x over cosine x, which is 2 times sine x over cosine x, cosine squared, times 1 over cosine x. So that's 2 tangent x times secant x. Okay, let's look at C. So C is sine x over 1 minus cosine x. To show that that's equal to 1 plus cosine x over sine x. So what I'm going to do is I'm going to multiply top and bottom of the left here by 1 plus cosine. Like that. So I'm going to leave my numerator the way it is. So this is going to be sine x times 1 plus cosine x. Denominator is going to be 1 minus cosine squared x. And 1 minus cosine squared is sine squared. So this is going to be sine x times 1 plus cosine x over sine squared x. 1 on the top and the bottom cancel, so I'm left with 1 plus cosine x over sine x. Okay, let's look at problem number 29. So part A, we need to solve this 4 times the sine squared of x, plus 5. That's going to be equal to 6. So the first thing I'm going to do is I'm going to subtract the 5 from both sides. So that's going to be 4 sine squared x is equal to 1. Now I'm going to divide each side by 4. And take the square root. So now I need to, for x, I need to find the angles whose sine value is plus or minus 1/2. Now remember, x is given to you is between 0 and 2 pi. So what I'm going to do is I'm going to look between 0 and 2 pi, how many angles have a sine value of 1/2, plus or minus? So there's a couple here. I'm going to draw them out. There's one here, so this guy at positive 1/2. This angle in here, the sine value, to get a height of 1/2, remember the radius is 1. So on the unit circle, that angle is pi over 6. Likewise, there's another angle over here that has a height of 1/2. Okay, so this angle going over is going to be 5 pi over 6. So we've got pi over 6, 5 pi over 6, but also, once we get down into the bottom, this angle has a height of negative 1/2. So don't forget about this negative right here. And likewise, down here, so this angle coming all the way over to here. This guy right here, if we add pi over 6 to pi, we're going to end up getting 7 pi over 6. Okay, and if we keep going all the way over, we're going to get 11 pi over 6. So these are the guys right here whose angles, if I plugged into here for x and solved this, I would get 6 out. Okay, let's look at 29b. So b is 3 sine 2x, minus 1 is equal to 1. Like that. So again, what I'm going to do is I'm going to move the 1 over, and I'm going to get 2 on this side. And I'm going to divide. So this is going to be sine of 2x is equal to 2/3. So I need to be between 0 and 2 pi. Now to solve this, okay, I can write it like this. I could say, okay, sine of some angle needs to be 2/3, which means that that angle, I don't even have to do that. You know, I'll make this much clearer for you. I'll take the arc sine of both sides. Let's grab our calculator and see if we can't solve that. So I need a sine value. I'm going to get it in degrees because it's going to be easier to see. So I need a sine value that is the sine of some angle. It's got to be 2 over 3. So we'll do the arc sine of that. Okay, so the arc sine of that should be 41.81. But we're not done, because think about that. What that's saying is there's an angle somewhere over here of 41.81 degrees whose height value, if the radius is 1, the height value is 2/3. Arc sine is only defined on these two, quadrants 1 and 4, but there's another angle out there. This is nothing about defining myself over quadrants 1 and 4. This says I got to find an angle between 0 and 2 pi. So there's another angle out there, which is over here, which also, it's hard to write over here on the side. It's also 2/3, radius of 1. And that angle looks like this. Well, what is it? Well, it's 180 minus this guy. So 180 minus 41.81. So 138.19. So here's two angles. But now let's be very clear. I can start adding multiples of 360, and I keep ending up with angles that have a sine value of 2/3. For example, I can take 41.81 and add any multiple of 360. Or I can take 138.19 and add a multiple of 360. And that will give me possible values. Now remember, these are equal to 2 times the angle. So what I need to do is I need to divide by 2. I need to divide everything here by 2. So let's just go ahead and write that down. So that's 21. Oops, well, clear. 41.81 divided by 2 is 20.9. We'll just say 20.9. It's easier that way. And 138. It's going to equal, say, 69.1. Again, where k is an element of the integers. So the deal is here, there's a lot of different answers. So I got to look for every k value that gives me answers out in here. So the first one is when k is 0, I get 20.9. So if you take 20.9, I'm going to let you do this. If you take 20.9, you plug it in here for x, and you do this whole thing out, I bet you get 1. Or really, really close, depending on our rounding, right? The next k value is when we plug in 0 here, which would be 69.1. So 69.1 is another value. When k is 1, I've got 20.9 plus 180, or 200.9. So there's another one over here at 200.9. I'll switch this to 360 so it looks better for you. Let's add 180 here. So 180 plus the 69.1 gives us 249.1. Let's keep going. Let's try k equals 2. Well, as soon as I put k equals 2, this is going to be 360 plus that, so it's going to be 380.9. And 380.9 is going to fall outside of our boundary. So these, now, once I've done that, I know that these 4 are the only ones for any of the different k values. So no matter what k values you pick, you're going to get something that's going to be outside of that 0 to 360 range. Okay, let's try the last one. So this is C. We've got 4 times the sine of 2x minus 2 times the cosine of x is equal to 0. So I'm going to take this guy right here and switch it. So I'm going to rewrite it like this. This is going to be 2 times the cosine of x times the sine of x. Now, what I'm going to do here is I'm going to factor out, okay, so I'm going to rewrite this like this. It's going to be, I'll write it like this, 2 cosine x times 4 sine x minus 2 cosine x. Now I'm going to factor out a 2 cosine x out of each of them. And now I got multiplication, so I can set them each equal to 0. So this over here is 2 cosine x equals 0, and this one over here is 4 sine x minus 1 equals 0. So this is cosine x equals 0, and this is sine x equals 1/4. So now I got to answer this. Well, I'm working between 0 and 360 degrees. So what angles in here have a cosine value of 0? Well, 0 does, and 360 does. Now let's just see if, when I wrote this down, I believe that I said it could be equal to 360, so we're good there. So here's 2 of your answers, so 0 and 360 are answers. And those are the only answers that I'm going to get out over here. So let's try this side. Well, when is sine equal to 1/4? there's going to be, you can have two shots of that. One is going to be over here in quadrant 1, and the other one in quadrant 2. So what I'm going to do is I'm going to take, on my calculator, I'm going to take 1/4, and now I'm going to take the arc sine of that guy, and I get 14.5 degrees. So we'll add that to our list. But there's going to be another guy out there that's also, here it is, that's also got that sine value. So that's going to be 180 minus that 14.5. So 165.5. And there it is.